Hey, Mr. Jones, this is our project on precipitation reactions. The one you assigned us was lead iodide, and this is Tom and Alex. So, first of all, what is a precipitation reaction? A precipitation reaction is a double displacement reaction in which a salt forms in a mixture of aqueous solutions. So a double displacement reaction, as shown below right there, is a reaction between four compounds in which the compounds switch. So you have A, B, and C and D, which become A, D, and B and C. And an aqueous solution is a solution in which the solvent is water. The solutes, in our case, were potassium iodide and lead nitrate. So how does this occur? Precipitation reactions occur when two aqueous solutions mix. The reactants are ionic compounds. When mixed, the ions in the solutions separate, creating a specific type of double displacement reaction. In this reaction, an insoluble product is formed. This insoluble product is known as the precipitate. So, our assigned reaction was a lead iodide precipitation reaction. Here we have lead 2 nitrate combined with potassium iodide, which yields lead 2 iodide and potassium nitrate. This, of course, is a double displacement reaction. So the actual experiment of our assigned reaction involves a solution of lead 2 nitrate being dropped into a solution of potassium iodide, forming a brilliant yellow lead iodide precipitate.
Alright, thank you, Tom. Now on to the formulas and equations of the lead iodide precipitation reaction. So the initial balanced molecular formula for the lead iodide precipitation reaction would be 2 moles of potassium iodide, which is aqueous, plus the lead 2 nitrate, which is also aqueous, and these two aqueous reactants would combine to form 2 moles of potassium nitrate, which is aqueous, but also the lead iodide precipitate, which is insoluble in water. The ionic equation we get from dissociating the individual ions from the initial molecular formula, and by doing so we would get 2 moles of potassium, which has a positive charge of 1, which is aqueous, plus 2 moles of iodine with a negative charge of 1, which is also aqueous, plus 2 moles of lead, which has a charge of positive 2, and this is also aqueous, plus 2 moles of nitrate, which has a charge of negative 1 and is aqueous, and all these aqueous reactants, again, combine to form 2 moles of potassium, 2 moles of nitrate, and again the lead iodide precipitate. And afterwards, by removing the spectator ions from the ionic equation, we would get the net ionic equation. And the spectator ions in this formula's case would be the 2 moles of potassium and the 2 moles of nitrate. And by removing those ions, removing those compounds, we would get the 2 moles of lead, which again has a positive charge of 2 and is aqueous, plus the 2 moles of iodine, which has a negative charge of 1 and is also aqueous, and these two reactants would combine to make the precipitate of lead iodide. And finally, we have a reaction demonstration of the lead iodide precipitating. So right here you could see the lead nitrate being dropped into the potassium iodide and forming the lead iodide precipitate, which is the yellow stuff right down here. And that's about it. Thank you for viewing.